Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 7.4, day 2, entitled Basic Trigonometric Equations. And again, we're going to solve trigonometric equations, but this time we're going to look at some factoring techniques that you can also use to solve them. Now remember, factoring is something we spent a lot of time on in chapter 1. It's one of those basic algebraic properties that you have to know. And the property that we're really going to be using is the zero product property. So that means that after you factor and you get your two sets of parentheses, you take each chunk or each set of parentheses and set them equal to 0 and solve them. So that's how you get your two little equations to solve. Okay, so we have 3 examples that we're going to work through, and they all involve factoring. Now this first one, if it helps to look at it in terms of x's instead of with the cosine thetas, kind of rewrite it off to the side if you need to. Okay, instead of 2 cosine squared x, or 2 cosine squared theta, think of it as 2x squared, and then minus 7 theta, think of that as minus 7x, and then plus 3. So that's usually how you see a problem that you want to be factored where it's a quadratic written with x's. So this one is a little more challenging to factor because it has a lead coefficient. It has that 2 out in front. And then we're going to have to check our outers and our inners as well, so we make sure we get the right combination to add up to 7 or negative 7 in the middle for our middle term. So I'm going to set up my 2 sets of parentheses. Now the factors of 2 are going to be 2 and 1. So usually I would do 2x and 1x, but this time I'm going to do 2 cosine theta and then 1 cosine theta, or just cosine theta. You don't have to put the 1 in there. And then I need the factors of 3. So now I just have to think, okay, where's the 3 going to go and where's the 1 going to go? So that when I check the outer terms and then the inner terms, I'll get 7 for my total. If I put a 3 here and a 1 here, my outer terms, the 2 times the 3, would get me a 6. And my inner terms, a 1 times a 1, that would get me a 1. So a 6 and a 1 can get me to a negative 7 if I make them both negative. So there's your proper factorization. Now we're going to use the zero product property that says you take the stuff that's in the parentheses and set them equal to 0. And then we're going to solve them like we did in the previous section of notes, the 7.4 day 1. So here I would add the 1 over to the other side and then divide by 2. Now I know the 2 locations on my unit circle where a cosine of theta gets me a value of 1/2. But again, think of your all students take calculus shortcut. The 1/2 is positive, so I need locations where cosine is going to be positive. So that's in the first and fourth quadrants. So if I think in my first quadrant, what radian measure is going to give me a cosine value of 1/2? That would be pi over 3. And then in the fourth quadrant, pi over 3, if I go down pi over 3, that's the same as 5 pi over 3. So there's my 2 radian values that give me a cosine value of 1/2. Now those are my principal solutions. I want to make sure I write these with general solutions. So I'm going to add the 2k pi on at the end of them. So again, pi over 3, and then if I go around 2 pi, that gets me another coterminal value that's the same as pi over 3. So I would keep going around and around and around and ending in the first quadrant. Same thing for the 5 pi over 3. I'd start there and then I'd add 2 pi, so I'd come around to it again and keep adding 2 pi's around and around and around. So I keep ending in the fourth quadrant. Okay, now I have to finish solving the other little equation here, so I have to add the 3 over. So cosine theta equals 3. Now if I tried to do this on my calculator, if I tried to do the second cosine of 3 on my calculator, it's going to get you an error message because cosine has to be less than 1 if we're going to take the inverse cosine of it. So this value here, this 3, is too big. So basically, that isn't going to get us any solutions. Okay, so we really only have 2 solutions for this one. Okay, let's take a look at example 7 here. And this one we're not going to factor so much with our guess and check strategies that we did in the previous example, but we are still going to factor. And if you look at your problem here, we have 5 sine theta times the cosine theta plus 4 cosine theta equals 0. And both of those terms have something in common. They have a cosine theta in common. So I'm going to take that out. So think of this as like 5xy plus 4y equals 0 if you want. I'm going to take out that y from both of them. So I'm going to take out the cosine theta, which will leave me with 5 sine theta plus 4 equals 0. Now there's still multiplication going on there between the cosine theta and the stuff in parentheses. So I can still use that 0 product property. So I'm going to set the cosine theta equal to 0, and I'll finish solving that. And then I'll have my 5 sine theta plus 4 that I can also set equal to 0 and solve. But let's go back to the cosine theta equals 0. Again, think on your unit circle. Now this is where cosine equals theta, and where cosine equals 0. And in your ordered pair, your terminal points around your unit circle, the x value is your cosine. So you have to think, okay, where is my x value 0? And that would be right here and right here on your y-axis. So the value for theta that's going to get me 0 is going to be pi over 2 and 3 pi over 2. Those are the 2 locations on my unit circle where cosine is 0. Now again, those are your principal solutions. So to make it general, you can add 2k pi to each of them. Now, technically, the distance from pi over 2 to 3 pi over 2 is pi. So if you wanted to, you could shortcut this a little bit and write this answer as just pi over 2 plus k pi, because then you would get the 3 pi over 2, and then you could go around to the top value again and bottom, up, down, and keep going around to those values. But it's good to have the 2 principal values shown in your answers. Okay, but I will write that other one in red here. You could have pi over 2 plus k pi. But usually we reserve that k pi just for tangents. So that's why we're not doing that here, because we want the 2k pi for cosine. All right, other little part then is to finish solving this for sine of theta. So I'm going to subtract the 4 and then divide by the 5. Now I don't have negative 4 over 5 on my unit circle, so this one I'm going to do on my calculator. You want to make sure that you're in radian mode. Okay, so far in this section for 7.4, we've always been in radian mode in our calculator. Okay, so you're going to do second sine, or sine to the negative 1, of negative 4 over 5, and that'll get you a decimal, and that's going to get you negative 0.93. Now remember, we're dealing with sine here. All students take calculus. And we want sine to be negative. So I don't want it to be here or here. I want it to be in the third and the fourth quadrant. So negative 9.3 would be down here in my fourth quadrant, just a little bit. Okay. So I don't really like to have the negative values written for my answer. So I would want to take 2 pi and subtract the 0.93 to get me my positive radian measure. So that would be 5.353. Okay, so 5.353 would be one of my answers, and then I would add the 2k pi on there to keep getting all the coterminal values in that fourth quadrant. Now to get the value in my third quadrant, I would want to take pi, right here, this is pi, and I want to go down a negative, or I'm sorry, up, however you want to think of it. I want to move 0.93 as well into this quadrant. So I would have to take pi plus 0.93. Okay. I want to add it because I'm moving around from 0 around the unit circle this way. So pi plus another 0.93. And that'll get me the same terminal point in the quadrant 3 as it did in quadrant 4 by moving negative 0.93. Okay, so that value then would be 4.07 if we round it. And then if I want to keep getting those values, those coterminal values, I'd have to add the 2k pi. Okay, so usually trying to figure out those values, how we get those decimal values, that's usually the tricky part for students. It's meant to be straightforward, knowing what quadrant you're in, and just think of you have to be at the x-axis, and then are you adding to go above it or subtracting to go down from it? If you're trying to get into the first or the fourth quadrant, or same thing here, if you're on the left side of the x-axis, are you adding to go up into the second quadrant or subtracting to go down? Or adding to go down, I guess I should say, and subtracting to go up into the second quadrant. So just thinking of what you have to add or subtract in order to move into the quadrant from the x-axis is basically the skill that we're trying to strengthen here. Okay, last example then is to solve this equation. Now this one looks different too because it's tangent to the fourth power. Okay, so it's tangent of theta to the fourth power minus 13 tangent squared plus 36. So think of it like x's if you need to. X to the fourth minus 13x squared plus 36. Now we can still factor that if it's x to the fourth. Okay, well, you have to think what times what is x to the fourth? Well, that would be x squared and x squared. So when I factor here, I'll do guess and check again. But instead of x squared and x squared, I'll have tangent squared theta and tangent squared theta. Then I'm going to need my factors of 36. That'll get me to 13. So that's going to be 4 and 9. And I need to get to a negative 13, so they both need to be negative. Now that we have it factored, we can use our zero product property and set each of those parentheses equal to 0. Okay, so the one on the left, I'm going to add the 4 over. Tangent squared theta equals 4. Now to get rid of the squared, I have to take the square root. So I get tangent of theta equals plus or minus 2. So I have two values here. Don't forget that plus minus. When you're physically taking the square root as part of your problem solving strategy, you get plus or minus in your answer. So then you have to do second tangent of 2 and second tangent of a negative 2 in your calculator to solve for theta. So tangent to the negative 1 of 2 and then also of negative 2. I'm just going to write it that way. You can't do plus minus in your calculator. We were doing one at a time. But you get positive 1.107 and then you get negative 1.107 as well. So just to save space here, I'm just going to compress that work and those answers with the little plus minuses. Okay. Now, the positive value here for tangent, remember we want all students take calculus. I get one positive value. Okay, I have tangent as positive 2, and then I also have tangent as negative 2. So I get a positive 1.07 and a negative 1.07. So the positive 1.07, that's okay. That's in my first quadrant here. Okay, that's right about there. And so I would have 1.107, and if I add k pi, that'll get me around to the third quadrant where tangent's also positive. Okay. My other value though, my negative value, the negative 1.107, is down in the fourth quadrant. Okay, it's down here. And again, I don't like the negative values in my answer as much as I like the positive values. So I'm going to have to take 2 pi and I'm going to have to subtract 1.107. And that will get me the 5.176 value. And then I can keep adding k pi as I go around. Okay. Now I have to finish solving the other part as well, my other little zero product property equation. So I'll have tangent squared theta equals 9 when I add that over, and then I'll take the square root. So I'll have tangent of theta equals plus or minus 3. So again, in my calculator, I would have to do tangent to the negative 1 of 3 and negative 3. I'd have to do them separately. And then when I do that, I'll get a value of 1.249 and negative 1.249. So just to save space there, I'm compressing or combining the answer with the plus minus. Okay, so one of my values, all students take calculus. The positive value, where tangent is positive, that's going to be here in my first quadrant. So that will be 1.249 plus k pi. So that gets me down here. And then my other value, the negative, is down here in the fourth quadrant. So again, I'm going to take 2 pi, and I'm going to subtract the 1.249, and that will get me my positive value, which is 5.034. And then I'm going to keep adding the k pi as I go around. So this one I actually get 4 answers for. That's a lot. I know the previous example we had 4 answers for that as well. First example we just had 2 because we saw a situation where the other equation gave us an error when we tried to type it into the calculator. And this example B, this is good because we're still practicing the movements from the x-axis. So we're trying to change some of those negative values into positive values. Now, it wouldn't be the end of the world if you left your answer as negative 1.107 plus k pi and negative 1.249 plus k pi. They're the same measurement, but usually we just like the positive measurements. That's just good mathematical form to put the positive measurement there. Okay, so here's some problems that you can practice. Practice these factoring skills. If you need to, rewrite the problem just with x's instead of sine or cosine or tangent theta. Sometimes that can help you see how to factor it because it's just in a little more recognizable form. There's not as many letters and symbols. It doesn't look as big and overwhelming. So there's no shame in that. If you need to rewrite the problem, you go ahead and do that. Remember that the solutions are worked out in the binder in the classroom. Check the answers in the back of the book. And if you have questions, come on in and see me before school.